Steve, you made me proud. I had palpitations. It was all great until I spoke.
Welcome everybody to this talk, and we are going to talk about Jenkins development with Minishift and shared libraries, and with Brokness. And give a big round of applause for those.
Come on in. Hello, everybody. My name is Rob Nestor. I am a senior software engineer here at Red Hat. If you can't hear me in the back, you can hear me in the back, I'm pretty sure. But if you can't, raise your hand. I'll try and project even more. So if you've been in this room most of the day, that's great. You would have heard a talk from Ari giving a high-level overview of delivering a host platform at the speed of light. Some of you were in here previously and heard Scott's discussion of container CI with Jenkins and OpenShift. And this talk will be about Minishift, which gives you CI/CD in the palm of your hand. And I encourage you, after I'm done, no matter how this ends, stick around and listen to Bill Peck. He's got some great lessons learned from implementing builder containers. So just a quick overview. We're going to discuss Jenkins briefly. I'm assuming most everyone in this room is familiar with at least the name. OpenShift, Minishift, and then we're going to discuss some local Jenkins development, and including shared libraries, which I think are very important for kind of the path that we're traveling with Jenkins. So Jenkins, continuous integration made relatively simple. It's one of the leading automation servers available, more than 100,000 known installations. Extensible plugin-based architecture. It's got a huge ecosystem. It's easily and tightly integrated with OpenShift. One of the things that I do want to comment, version 2 of Jenkins introduced the concept of the pipeline, and we have leveraged it heavily within our group. And I encourage you, if you've been using freestyle jobs, stop. Use pipelines. They're much better. So OpenShift. OpenShift promises ease of use without worries. The promise is that it makes the development of containerized applications easier, faster, because the developer does not have to worry about any of the IT aspects, infrastructure, routing, any of that kind of thing. And it does, until you have to actually do it yourself. Here you can see a diagram of a fairly typical OpenShift installation. You've got masters, nodes, persistent storage, all these kind of things. If you're a developer, chances are that you're far more interested in actually doing development than doing system deployment and configuration. And if you're the type of developer who's like, no, I love that kind of stuff, chances are you may not even have the resources to do a full multi-system installation. And even if you have all of that, your time really should be spent doing your application, shouldn't it? So we know that OpenShift is valuable. We know that we don't want to necessarily fiddle with the infrastructure nuts and bolts. So Minishift. Minishift does an awesome thing. It deploys a single node instance of OpenShift inside of a virtual machine on your local system. So what does that mean? That means you don't need to contact anybody to deploy an OpenShift environment. This OpenShift environment that gets spun up could be designed to match exactly what your production OpenShift environment looks like. That's actually the path that we took. Specifically, we had a couple of goals for why we used Minishift. One was that we wanted to be able to have a local dev that matched. Second, we wanted to be able to prove out PRs before we push them. If we can test locally in a development environment that matches our production, we don't have to git, push, and hope while our stage environment checks all of our PRs. One thing that this kind of allows us to do as well is Ari had actually went through and Ansiblized the deployment of a development environment. Every time we onboard a new employee, instead of going through this hassle of, oh, how do we do this, and there's a manual process for that, they can just clone a repo, run a deployment playbook, and they have a development environment. It's pretty straightforward. So how easy is Minishift? Well, it's pretty simple. Issue the Minishift start command. It brings up a default configuration of Minishift, which is 2 gigs and 20 gigs disk space for the virtual machine. All of that can be customized. You can either customize it on the command line, or you can set your defaults to be whatever you find appropriate. You can also run multiple profiles of Minishift, which is kind of useful. Once the VM starts, it pulls the OC binary, it pulls the OpenShift container, it deploys the server, and you can log in. At that point, start with your applications. Now, I didn't speed this up. This is pretty much the way that it goes, with the exception of maybe your network bandwidth may limit some aspect of it, but it's pretty straightforward. So, the video that you saw gives you a default configuration of Minishift. Well, what if you need more customization? By default, Minishift boots boot to Docker. So it's just executing the container, it does nothing else. Well, what if you need more services or other technologies? Minishift actually includes a CentOS Live image built in, so that gives you a little more customization. What if you need way more customization? We actually found that for our dev environment, we needed to be able to allow for nested virtualization. Well, that's not by default on CentOS. So you can actually roll your own custom ISO. It's a templated process. It's really straightforward. And then you can provide the path to your new ISO when you start your Minishift instance. It's well documented. The guys at Minishift have done a great job of detailing how that works. So now we've got this cool little Minishift instance on your local machine, and you've set Jenkins up in it. So what can we do? Well, like I said, Jenkins 2.0 introduced the concept of pipelines. Basically, Ari made the comment of pipeline as code in his talk. And that's a great way to think about it, because instead of having a job configuration that you have to export out of Jenkins and then figure out, was this the last version we had of this after so-and-so changed it or whatever, it can actually end up being in source control. The other aspect of pipelines is that they serve to highlight certain patterns. When you're doing freestyle jobs and things like that, it's easy to kind of just, I need this step and this step and this step, and you don't necessarily think about the repetitious nature of what you're doing, or the repetitious nature between jobs sometimes. The patterns that get highlighted when you start doing pipelines are low-hanging fruit for some refactoring. So keep your pipelines dry. Refactor the code that you're seeing, the pipeline code that you're seeing, into shared libraries. Now, shared libraries, they're written in Groovy. If you're a Python person, don't freak out. It's okay. Groovy's kind of like Java for people who like Python. I'm one of those. So said from someone who likes Python, it's not painful. Your shared libraries exist in source control, so awesome. We can actually have a history of did we screw something up in this PR for the shared library, or is it something else? So shared libraries in Jenkins can be defined at a global level. You can choose to implicitly load a shared library, which means it's available to every project, everywhere, anytime, without any other interaction from you. You can also define it in the pipeline as well. So let's say that you need a specific shared library for a specific job. You can actually just put some information at the top of your Jenkins file, and hey, I can actually specify the Git repo and what branch and even revision that you want to pull. So shared library structures. There's an expected structure for these. There's a source directory, which, as you can see, kind of is a typical Java class path, nothing too crazy. And then we have a vars directory. The resources directory, now it's interesting because there's not a lot of use of that in our environment, and then also kind of, I think, in the community at large, that's not being used very much. Any valid Groovy can be used when you're constructing these shared libraries. Jenkins steps can be accessed in methods outside of enclosing classes in the source directory. One thing I will tell you, and one gotcha that plagued me when I first started doing this, was that if you have a Jenkins file that is being loaded from source control management, then you actually can run into issues where you write these great Groovy methods, and you're like, yeah, it does this thing, and that's awesome. And you go to execute the pipeline, and it fails because it can't actually run the Groovy method because it's not whitelisted. So those are things you can run into. If you're not implicitly loading a library, you may have to run the job and then go whitelist a method and then go run the job and repeat ad nauseum. The vars directory really is designed to hold scripts that define global variables, and we'll talk about those a little bit more. So one of the benefits of shared libraries is refactoring repetitive pipeline code. When I started this process of refactoring, our Jenkins file was 832 lines of code. Now, I don't care if it's simple or not, 832 lines, you kind of just glaze after you read it a little bit. Just by doing some simple refactoring into shared library methods, we were able to cut that in half plus some. Makes for easier maintainability, easier readability. We know that we have a method that fits all of our use cases, and we can actually extend it easier. So I talked about the idea of the vars directory. When you start looking at your pipeline, entire segments of your pipeline can actually be refactored into these ideas of like Jenkins steps. If you've used the pipeline at all, there's the idea of there's a DSL that exists. You can call a get step, you can call a shell step, those kind of things. You can actually take those concepts and extend them and create the idea of your own custom Jenkins steps. This is an example of one. It's pretty simple. It's an equivalent of a hello world. But in our Groovy file here, we've defined a call method. And the call method could take either simple args, it could take a block closure, whatever it needs to do. But what it allows for is to then be called from the pipeline in a similar fashion as what you would do for any of those other Jenkins steps. So you can see here that this is a sample Jenkins file below that's calling the say hello method, passing an argument to it or invoking it with just default arguments. So this is something that I think a lot of people have been interested in the previous discussions this morning, where both Ari and Scott mentioned higher level DSL. And what does that really mean? Well, you can actually take these shared libraries and start to craft not only steps, but entire series of steps that simplify your workflows, that simplify your approach to your pipeline. So in a single pipeline, you'll have repetition, and you can simplify that. And you start looking that really from every pipeline you're doing, you're more or less doing the same processes. You're probably provisioning infrastructure, you're setting up logging, you're doing test execution, you're doing reporting, you're tearing down that. So I mean, these are patterns that we see repeatedly. So if in your projects you're saying, okay, we're doing this, and most of these jobs we're changing maybe a couple of arguments that we're using, you can start to explore the idea of a high-level DSL. What we're doing, what we're trying to do, is to implement this DSL so that teams that get onboarded to our idea of what the pipeline can be, they can leverage our shared libraries. They can use a kind of a convention YAML-based config file to simplify the execution of validation, things like that. So to give you a quick breakdown, someone asked, in a previous talk, what would your config file look like? Here it is as a draft spec. Now, this isn't a finalized kind of thing. But basically, we can define that we want cloud infrastructure, what type, how many, containers, what our reporting wants to look like, what our testing should look like, and all of that can live in the repo of your project. Now, some of the things, we showed the example of provisioning a cloud service. So this would be an example of a method that would live inside of our shared library that does this. And this actually does this. I mean, we have this working. In this case, it calls out to an Ansible Tower instance and then deploys AWS hosts. So the end result of the Highlevel DSL is you can write really boring Jenkins files. I like boring when it comes to code because it means I don't really have to work too hard. And I love writing code, but I like not having to work too hard in maintaining it. And so, with this kind of structure, this is what any of your projects would possibly have to have for a Jenkins file. And if you only had this, it becomes much easier for you to actually implement it. And so that's one of the big advantages of the high-level DSL. So, any questions before I wrap up here? No? Okay. So basically, like I said, Minishift gives you an OpenShift environment. It's highly customizable. It's local. It's easy. Jenkins pipelines are good. If you're not using them, use them. Keep pipelines dry. Shared libraries should always be used if you have any repetitious code. There's no real downside to it. You can write your own. You can leverage third party. In our organization, we actually leverage the shared library from the CentOS group. For some methods, we contribute to that. If we have generic methods, we have our own internal shared libraries as well. And a couple of references, Jenkins, OpenShift, Minishift, the Groovy language reference for the Python people. It's, like I said, it's not that bad. And then some additional Jenkins documentation for shared libraries. If you have questions, feel free to give me a shout on Freenode. I'm Rob Nestor. And then I've got a link here for the slides, which if you guys want to grab those. So questions, comments, anecdotes, funny stories? All right. Yeah, Mike.
Can you use shared libraries from scripted and declarative?
Yeah, you can. And in fact, declarative really pushes you towards shared library usage because in scripted, it is highly flexible. You can basically throw Groovy anywhere in there and it'll work. With declarative, they are much more specific on where things belong and what belongs where. And so you can still do bare Groovy, but it's purposefully difficult because they want you to actually move towards using these shared libraries.
When you will release a new shared library, when you, let's say that you will release a new shared library that is maintained by your own, how you will trigger the review of all Jenkins jobs that are depending on?
Sure. So the question is, if you make a change to your shared library, how do your jobs know? How do you make sure they're pulling the latest version? So that's actually one of the nice things about shared libraries. If you define them in your global configuration, you can give it a branch to always pull. So it can always pull master, for example, or whatever your project's best practice branch is. If you want a specific tag, it can do that. If in your Jenkins file, when you define a shared library, you can define a branch or a specific tag or a specific revision, even if you want to peg it to something. So there isn't anything that you have to do.
Yeah, but I was talking more about the control model, so not the latest greatest.
I'm sorry?
I'm talking more about control model, which means not the latest greatest from master, but to automatically, let's say, increase the graph
I'm not sure I'm following your question. I apologize.
Let's assume, because you mentioned that you can keep your library in the branch, which will end up in the situation that you will get the latest one from the branch each time. But what about if you will put the exact tag into the library statement, and you will create a new tag, and then you would like to roll everywhere it's referred.
Okay, so if I understand your question correctly, and correct me if I don't, if you've specified a tag, how do you then update that configuration globally? Well, there's a couple ways you can do that. One is if you are doing it within your pipeline itself, you could actually do a commit on the pipeline, the Jenkins file itself, to update it, and that would get pulled every time you run the job. So that's one approach. I think globally, I don't know if there's really an answer. It's a good question, but I think the one way you could ensure that if you had these jobs, throughout would be, making a change to the Jenkins file and source control as well.
How do you test your shared libraries? Do you have some unit tests, but do you rely only on Jenkins?
So that's an interesting situation because you start writing some of these things and you go, if it's Groovy, you can kind of do your typical unit test. If it's pure Groovy, and those kind of things, and you should. You can also include Jenkins DSL stubs and things like that, which complicates the ability to write a normal unit test in Groovy. There was a presentation, 2016, I think, at Jenkins World, where someone did a great presentation. This was 2017. It was a great presentation on unit testing for Jenkins. And it's awesome in kind of small doses. And I say that because they're just, I don't think their project is at the point where it handles all the aspects of declarative, scripted, and things of that nature. So even trying to do a unit test with that is somewhat challenging. Like I said, if you're writing pure Groovy, write Groovy unit tests. If you're writing these kind of mixed methods of Groovy and some Jenkins DSL calls and things like that, it is more complex. Now, what we do in our group is that every change we make to a shared library goes through this validation process, and actually, we test, have we broken anything in any of our stages? Does it cause problems in any of our containers? That kind of thing. So we do have validation, but it's not at a unit level. Any other questions? No? Going once. All right, we're done. I think it's because it's closed out. You know what I mean? Like, I think something has focus. Yeah. So I think that, I don't know, but give it a whirl.
So you end up just falling back to